have a mystery kit here. I don't really know what it is, and I ordered it some years ago actually. But let's see what we can glean. So there's a printed circuit board. It mentions the LM324, which is an op-amp chip. There's a couple of those. And we have LEDs, resistors, that symbol there I think might be a thermistor, and that's the variable resistor preset. So we have a couple of chips here, the LM324 sockets as well, which is nice, and a whole load of resistors. And actually it comes with instructions, a schematic. So we have the LM324, so it's actually multiple gates per chip, so four op amps per chip. And I can see the configuration from the configuration of these, they're being used as comparators. So the voltages on the plus and minus pins are being compared, and on the basis of that, the LED is going to light or not light. And then we've got this chain of resistors, so these are different. So this is like a multiple voltage divider, so you've got different voltages for the different chips, so they'll light at different voltages. So it's some kind of bar graph display based on the voltage comparison. And then we have the preset here, which is going to be used for adjusting, calibrating. And this other component here, if that is a thermistor, let's see what we've got here. Look at that. So it looks like a signal diode, but I think that's a thermistor. So it basically changes its resistance based on the temperature. So I suppose this is like a digital thermometer type thing, but we can do better than that, because there's an app, of course, that allows you to read Chinese. Let's have a look. So the Google Translate app. So if we set it up for Chinese, let's look at the camera. And this says LM324 temperature indicator kit. So yeah, it's some kind of thermometer. You see, this app does quite a good job of translating the Chinese. What can we see from the instructions? Thermistor and resistor are connected to the non-inverting input of the voltage comparator. The thermistor, a negative temperature coefficient thermistor connected in series. Right, so look at the other side. This is the component list. Yeah, so R19 is negative temperature coefficient thermistor. And I think what that means, negative temperature coefficient, means that as the temperature goes down, the resistance goes up. So it's like the opposite sense. So let's get the soldering iron out and start adding some of these components. One thing that's quite neat about this, actually, looking at the schematic, is that all of these current limiting resistors for the LEDs are 1K, and everything in the voltage divider ladder here is 1K. So that's quite a nice piece of design, that you end up with all of the resistors the same value. So that certainly makes assembly quite straightforward. There we are, all the resistors in place. Doesn't matter where they go because they're all the same value. So I just have to solder them in now. I think that's it. Let's clip the wires off. Oh, I think I might have just broken a track there. When I moved that pin, it made a cracking sound. Check the continuity. Might be all right. I'll just reflow the solder there. looks okay. Perhaps put the chip sockets in next. The legs are all straight. Not quite. Just make sure they're seated properly before doing all the pins. Okay. Okay, looks all right. Maybe that one there's a bit dry. Oops. Just bridge the connections. one could do with a bit of extra attention also, I think. Good. I guess I could put the thermistor and the preset. Ow. Just stabbed myself on a sharp connection there. Ow, ow, ow. That was the Spitfire flying over. Right, what's left? So we've got the LEDs 1, 2, 3, 4, 5, 6, 7, 8, and the power wires here. Right, so I think we'll go black for negative. Oh dear, bridge them together. My desolder pump. And finally the LEDs. Let's just give them a quick check. Oops. Okay, that's good. Putting the long leg nearest the resistors, because that's the anode, and the schematic, you've got all of the cathodes here connected together to the ground. Quite useful to have a circuit diagram. They're not always provided with these Chinese kits. Okay. Bit fiddly. I just want to put a bit of solder on each leg so that I can then position them correctly before doing the other leg. So if I push this through now, so that's nice and flat against the board, so that's what I want to do. It's just melt the solder a bit, push the lead down right onto the board, and then let it sit right, and then I can go back and sort the other legs out. looking good. I do try and fill all the holes with solder. I don't like to see the bare copper or be able to see the holes. Need to have enough solder in there to make a good connection. That looks good now, I believe. And there we are. So that's assembled. Just check over, make sure I haven't got any bridged connections. There's enough solder on all of the various pins. Yeah, I think that's all right. So let's get these LM324s in place. Somewhere in the house I have a chip insertion tool, but I haven't seen it recently. I don't know where it is, so I'm just going to have to fumble my way through. Right, I think that's good enough. Right. So, does it say what the voltage is? Oh yeah, power supply voltage 5 volts DC. Okay. Let's go. So, here we go, moment of truth. Oh, so we've got a few LEDs on. 6 of the 8. So, if I get a small screwdriver, we can turn the preset, so that's full scale. And then if I heat the thermistor, we should change the display, I guess. Isn't doing much. Perhaps this is the sensitivity. If I turn that up. It's not doing a huge amount. Perhaps if I put the soldering iron on it, let's try that. There we go. Yeah, so if I heat it up with the soldering iron, it actually starts to change reading. So if I turn that right down, let's try it from the bottom. There we go. So it does need some quite significant heat to actually change the reading. So can't say it's hugely useful, but there we are. So a digital thermometer with a bar chart readout.